So what is an infrastructure? So an infrastructure is basically basically the software set of machines, network, load balancers, and a lot of different devices that your company uses in order to run your softwares, right? Run your software in the cloud. It can be either in the cloud or it could be in the on premises. Every company will have an infrastructure on top of which they run their applications. And this infrastructure could consist of, when we talk about the core level or on a very low level, this infrastructure would consist of different networks, and there would be a number of machines which are connected to this network, and these machines will be communicating to each other, and then you would be running your applications inside these machines, and these applications talk to other machines running other application over network. And then sometimes you want some kind of load balancers in order to manage and provision, to do some kind of load balancing in your applications. You might need storage devices when you have some important data that you want to store. You also want some kind of auto scaling groups. You want the machines to be created automatically based on the demand, and then the machine get deleted when you don't have that demand. And then you might need some caching devices where you want to store some temporary cache, or you will have a lot of things. You will have some databases, right? Databases which may be either created in the cloud, or it could be somewhere in your premises where you have set it up yourself. Or there will be a lot of things that you need as part of your infrastructure. If you want to run your application in a proper manner, you need a lot of things to be part of your infrastructure. So I will talk about few components that you can expect inside an infrastructure. Definitely there will be some kind of network. There will be some kind of network, and there will be lots of machines. That is some very basic infrastructure. Most of the infrastructure would consist of a number of machines, and most of these machines are connected to each other over a network, and they run different software application that your company deploy into them. And all these machines will be able to talk to each other, probably when they want to communicate and transfer some data. All the machines will talk to each other, and that's how it actually works, right? Great. So there would be network, there would be machines, there would be some databases, right? There would be some databases that I have already told you, and that is where generally your different applications running across different machines want to store data inside a database. So there can be database devices, and sometimes there can be some kind of caching devices, right? Probably if there is some temporary data that you want to store somewhere, then you need some kind of caching server. And in order to do that, your different applications might want to store different cache inside a caching server. So you might need such kind of cache storage, database storage. You might also want some kind of load balances. Sometimes you want to run same application in multiple machines. So in such cases, a load balancer is preferred. Every time somebody want to talk to your application, they will speak to the, assume this is somebody. It could be either your customer, or it could be some internal application that your company on, and this want to talk to some other application that you have deployed into different machines. It's not only one machine. This application is running due to heavy load that is coming to your infrastructure. You are running this same software in multiple machine, and all the machine need to be load balanced. For example, 10,000 people or 30,000 people are connecting to your application. 10,000 requests should go here, 10,000 should go here, and the remaining 10,000 has to go here into the third machine. So there should be some kind of load balancer that sit in front of your machines, which will take care of the load balancing, sending traffic to individual machine. So then internally all these machines might want to speak. So there will be a lot of different components that an infrastructure will consist of: load balancer, storage devices, and a lot of stuffs like this. And think about a company whose infrastructure has grown very big. Think about Amazon, think about Flipkart, think about a company who need hundreds of thousands of lakhs of machines or millions of machines, right? The companies like Amazon will have millions of machines to run their infrastructure and provision different software applications. So so the infrastructure can become complicated over time, right? And how this infrastructure need to be managed, right? That is what we will talk about. So I will just talk about some history, how things were, like 10 years before or 15 years before when I started working, and then how things has evolved, right, over time. So I will give an overview how how things has evolved. So first of all, 15 years before, the infrastructure was not this much complicated. It was kind of uh, yeah, some companies needed such heavy infrastructure, but it was not a requirement for most of the company. And also the software expectations are not this much what we have today. So every startup company, they will have an infrastructure, and most of the time they would be using different scripts, right? You can actually write some script to provision the machine, create the machines, manage the machine, configure software inside the machine. So all these things can be done using some script. That is one option. And otherwise there are different coding solutions also available, such as Puppet or Chef. Plus, using such kind of tools also, you can do some infrastructure provisioning. It is technically possible, but and most of the people were doing a lot of work manually. Manually, what that means is you are your engineers are responsible for managing the infrastructure. So again, that is much more complicated. So I'll give a brief overview about the history, how things has evolved, and then you will get a clear clarity on why IAC is a need of today. Right? I will get into that. Right. So let's talk about some history about the infrastructure. So when I started working, right, when I started working, my responsibility was to manage a data center. And actually we are paid based on the number of server that the data center has, right? Basically there would be a number of people who are assigned to set of surveys. So you are responsible for X number of machine. One engineer is responsible for some 20 machines, or the next engineer is responsible for 20 machines. So if the company has some thousand machines, you definitely need at least a very big team to manage it, because a lot of manual work, a lot of scripting need to happen in order to manage all these machines, right? Scripting solve the problem to a good extent, but it is not a perfect solution. When you write some script to manage or provision your infrastructure, it can become more and more complicated later on. So when you want to create the machines, or when you want, sometimes it is a virtual machine that you want to create, that can be automated using the scripted installation. And sometimes you want to buy a physical machine, and buying a physical machine has to be definitely a manual process. You have to order the machine, and the machine need to be no, you have to coordinate and the machine to be delivered to your data center. And there should be some work done by the data center engineers inside the data center to set up the machine. And so the whole process takes a lot of time, maybe week, or sometimes, if the machine is not in the stock, it can take up to 1 month or 2 months. So those many takes it would take to provision a physical machine. And if you have the physical machines, then provisioning a virtual machine inside the physical machine is probably, you can automate that to an extent. Either you can do it manually, or you can do it using the script also. And again, again there would be a lot of such kind of machine that you want to create based on the company requirement. So assume I am managing some 30-35 machines that my infrastructure has. Then I am responsible for a lot of things. I am responsible for creating the machine. I'm responsible for installing different software into those machines, and then setting up the machine. Then after that, I want to set up some monitoring on the machine. So in order to do that, I would create one extra machines, and that machine will be running some monitoring software, and that monitoring will be monitoring all other machines. So a lot of complicated work is what that an engineer used to do when they wanted to manage the machines. And most of the time there can be some error in the data center, there could be some network issues that can happen, there may be a power shutdown, or due to some problem in the data center, any of these machines can go down. In such cases, you probably want to create some extra machine to replace the machine that is currently unavailable, and then you need to solve the problem. And again, it involves a lot of manual work. And sometimes you want to install some updates inside the machine. You want to install some security update, and different management needs to be done. So you have to manually either manually do that or prepare some complicated script to do the job. And sometimes the script might have to handle different machines, maybe different machines are running different operating system, then I have to write operating specific code inside my script. And the script can, at the end, the script can become very complicated. You would be mostly like working like a developer to manage such kind of things. And then this script need to be maintained by you, then that is again another headache. So because of that, and the most important need is the human power. A lot of people are needed in order to manage the machines. If you have one person is managing 20 or 30 machines, think about if you have 100 or thousands of machines, you need a very large team, and all teams would be doing a lot of manual job, writing a lot of scripts and stuff like that. Then when the infrastructure is already complicated, then all the manual work and scripting that you do will make your infrastructure more and more complicated. And over the time, it would become very difficult to manage. And then yeah, so instead of doing such kind of things, there are a lot of tools evolved over time. Puppet and Chef was, they are there for a very long time. Most of the companies started using Chef or Puppet. They are not only for provisioning the infrastructure, they can be used for provisioning the infrastructure, creating the machines in your cloud provider, then creating a virtual machine inside your hypervisor. All these things can be automated using such kind of tools, but also those tools are also kind of a little bit complicated, but the tools solved most of the problem to a very good extent, right? These tools such as Puppet or Chef can be used to provision your infrastructure and then run some software inside the infrastructure. And all these things can be done, so they solve the problem to a very good extent. But again, these tools are not very much native to the infrastructure. They can be used for provisioning the infrastructure, but the tools are actually much more complicated. The tools are designed for not provisioning the infrastructure, but rather for the configuration management, just like Ansible or other tools. Chef and Puppet can man the configurations. If Chef has the information about a given machine, and provisioning the infrastructure was something that was a additional layer that these tools used to have. And they have been, many people started using these tools to manage their infrastructure, provisioning the machines, especially when with the cloud. These tools can easily provision new machines and do a lot of work. And that is one great thing. And then people started thinking about developing the infrastructure just by writing the code, rather than doing a lot of manual work, doing a lot of complicated scripting to provision the infrastructure. Think about this: how you can work as a developer. You can work as a developer and you can write some kind of code. You can write the code about how many machines that you want, and which cloud provider, whether it is AWS or Google Cloud, or whether it is VMware. It's up to you whether it is a virtualization provider, or what is the kind of infrastructure that what is the kind of cloud provider or the virtualization solution where you want to create the machines, how many machines you want to create, and what is the size of the machine that you want to create. And then the machine should belong to this particular group, and a different set of machine belong to this particular group. And then you can actually also configure what the machine to be provisioned with, what are the initial installation to be done on the machine. So whatever you want your infrastructure to look like, you can write it as a code, right? You can write it as a code. So instead of writing a script or provisioning the machines in my AWS cloud, think about this: you are using AWS as your cloud provider, and instead of provisioning machines manually in my AWS infrastructure, assume I am writing a code inside a file. I'm going to write, I need some 4 machines to be provisioned in my AWS, and they should be T2 medium machines because that is the size that my application support. And all the machines should be connected through a load balancer. There should be an application load balancer. The load balancer has to sit in front of my 5 machines. So I have a software that I want to run across some 5 machines, and then in order to assume a lot of traffic is coming, and that's why I am keeping 5 machines to run this application. And then if you are running 5 machines, you must also have a load balancer. So there would be a load balancer that sit in front of the machines, and then the load balancer will send the traffic to all the individual machines. So that's what it is. So this is how it will look like. And then probably the machines will have some storage device that they want to use. They want to store data in some assume in some cloud database. You have a RDS database or some cloud database, and that is where you want to store all the data. So you would specify that information also inside the code to create a MySQL database or whatever database that you want to create. And then you can configure your machines to get the information about this database so that the machines can start talking to the database. And then probably you also want some caching software. You need some kind of caching to be done. So you want to provision a caching device in the cloud. And this caching device is where all your applications want to store the cache. So like that, you have an infrastructure requirement, but whatever infrastructure that you are expecting to create, you don't do it manually. You just write it down inside a program as a code, right? As a code. I'm not talking about very complicated code. I'm talking about very simply formatted code that anyone can write without programming skills. You can still write such kind of code, and then you write it down. You need the load balancer, you need the database, and I need to get the IP address of the database, IP address of the database to be given to my application. And then I want to provision a caching server, and the IP address of the caching server should be given to the application. So like that, I will just write whatever I want to write. I write them down inside a file, and then some tools that can read this file and apply the settings to your cloud provider. So your cloud provider is, assume it is AWS. So you have AWS, and then assume some tool that allows you to write such kind of code, and then take this code, then understand this code, then provision an infrastructure in your cloud account with one single command. So you'll run one single command to execute this file or execute this code. Then the tool can read this file, understand the kind of infrastructure that you want to create, and the kind of connection that different machines and the load balancer should have to each other. It will establish everything, and it will provision a complete infrastructure. So think about that. So this is how the infrastructure need to be managed today. And if you manage the infrastructure in that manner, the another additional advantage what you are getting is that you don't really need any extra documentation about your infrastructure. Otherwise, what on the old days what we used to do is we keep some kind of Excel sheet, or we keep some kind of very very large file to create a proper documentation for everyone. For this machine, what are the different software to be installed on the machine, what are the different services, and which cloud provider it should be provisioned, and for this application how many machines to be provisioned, how many database to be provisioned, how many caching server to be provisioned, how many load balancer to be provisioned, and how they will communicate to each other. All these instructions we have to create big documentation. So you don't have to create any more documentation, because how you want your infrastructure to look like, it is already written as code inside a file, right? Inside a file it is already written as code. So you don't really need any extra documentation. So assume this file is managed by a team of DevOps engineers, and every DevOps engineer have access to this file, and they can take a look at this file. They will understand, okay, this is what my infrastructure need to look like, and they don't need to do any manual work. Whenever they want to apply these settings, they can just run the settings, and an infrastructure get provision in the cloud. And that is one advantage. And the other advantage is that you can delete and recreate the infrastructure whenever you want, right? Probably you have a production infrastructure that consists of 50 machines, and then 10 databases and one caching server, and 5 load balancers. So you have such kind of a production infrastructure, and then you want to create a development infrastructure. So you can reuse the same code, and you can reduce the number of machines. Instead of 50 machines, you will keep only 5. Instead of 5 load balancers, you will keep only 1 load balancer. So the code will be same, but the count would be less in the development infrastructure. So every time you want to create a new infrastructure, or you want to delete an infrastructure, you don't really have to do any extra job. You already have the code, and the same code can be reused for provisioning different infrastructure. Or your company decided that you expand your services to a different country. Right now, the company is serving India, and then your company decided that you want to serve other country also. You are expanding to United States, so you will create an AWS account, a separate AWS account, or maybe you want to provision an infrastructure in the US region within your AWS account. You can use the same code that you are using in India to provision an infrastructure in the US. You don't really have to do all the rework, manually creating a lot of machines, load balancers, managing their connections, and all this complicated stuff you can get rid of. You can use the single point of truth, right? Your code would become the single point of truth, and it can be reused to provision the infrastructure based on your requirement, what your company has. And that is another advantage. And then also you will get a pre-defined infrastructure with proper versioning in it. So as a company, you want to keep on making changes to the infrastructure, right? And that is another thing that you want to do. So okay, I'll talk about that also. Give me one second. That's what I'll talk about next. So why the infrastructure change need to be revisioned? That's what I'll talk about next. So in your company, you keep on changing your infrastructure. You keep on adding more machines to your list, or you keep on deleting the machines, or sometimes you want to change the load balancer. You want to add some settings need to be changed on your load balancer. You want to add some extra machine to the load balancer, or maybe you want some listener settings to be changed on the load balancer. So you might want to add some extra port on the load balancer. You want your database to be accepting connections. You want to modify some security group settings, so that database will start accepting connections from all the new machines that are getting created. So you want to keep on making some change to your infrastructure, and that's what you do. Maybe a good amount of time of a DevOps engineer is spent on making changes to the infrastructure, and that is something that as a company you continuously do, right? You want to add more machine, change the setting of the machine. You want to resize the machine from T2 micro to T2 medium, or T2 medium to T2 large, right? Based on the change of need that happens in your company. You want to keep on changing different things. So when you want to change the infrastructure, you can actually, how you change the infrastructure? If you are writing the infrastructure as code, you will change the code, right? Change the code. And every change that you make in the code resemble a change that you want to make in your infrastructure. You agree with me? Every time you make a code change here, because the code is nothing but your infrastructure, right? So it is your infrastructure that is written as the code. So no, you want to do something, you decided that you want to add some 10 extra machine to your infrastructure. So you will change the code, you will change the number of machine. Assume there's a variable called number of machine, and that is the variable that you use to decide how many machines that you want to have. So you decided that, instead of previously it was 80, I want to change the number to 100. So so basically, when you change the code, what that means is your infrastructure is going to change. You are going to get some 20 extra machines inside your infrastructure. So every time you want to change your infrastructure, you make some change in the code. And assume you track the changes, right? You can track the code changes when you are using code. You can always track your code changes in a source control management system, something like Git or SVN, or some source code management tools are available today. So every time you make some change in the code, you can actually make a commit and make a record of the change what you are making. So the point what I'm trying to make here is that every time you change something, every time you change the code, you are actually revisioning a new version of your infrastructure. So just like your application, your development team work on the code and develop the application, you work on the infrastructure and develop the infrastructure. When you change the infrastructure, you call it version 1. You change it again, you call it version 2. You change it, a lot of changes, you can call it version 10. And then all these versions that you created so far, they are the history of the code. And anytime you want to do some rollback, or anytime you want to go back to v9 or v8, you can go back just by using a single command. So when you define your infrastructure as code, then making changes to the infrastructure means making changes to the code. And making changes to the code can be easily tracked and managed very efficiently. So every time, assume I have a lot of DevOps engineers who work inside my company, and they keep on making changes to the infrastructure, and that is what their job. They have to change the infrastructure, and they are managing the infrastructure. So this guy added some 20 machines and made a commit, and this guy want to add a new listener to the load balancer, because some application need to be exposed, some extra application need to be exposed on the load balancer on port 8080. So this person has added that settings. So this person need to increase the size of the machine. All applications, he is one by one, he is migrating it to T2 medium. Currently they are running T2 micro. So whatever they do the coding. They always do the coding, and when they make the coding, whatever code change that they do, and for each code change, they make a version. So v1 or v2. I mean, I'm just saying, it could be it could be a git commit maybe, or it could be some git tag, or it can be anything. So you can version this code very easily when you are doing the code, and then each code or each record represents a different version of your infrastructure. And at any point of time, whatever infrastructure that you want to create, either you can create it from v4 or you can create it from v3 based on your preferences. If v4 is buggy, or some customer want v3, some customer want v1, you can choose whatever version of the code that you want to take to provision your infrastructure. So you have this flexibility. The DevOps engineer can work on the code rather than writing a lot of complicated script and doing a lot of manual work by logging into the AWS console. So they don't really have to do that. They can instead, whatever they want to do, they can write it as a code. So writing the code for everything is kind of a new work culture that the DevOps engineers are nowadays adapting, right? The operation team or whoever is managing the infrastructure, they should be writing the code, and in the Ansible training, right? You all took Ansible training, I guess. So in the Ansible training, we have already seen how to write the configurations as code. Here we are going to write the infrastructure as the code. So it could be cloud. I mean, infrastructure as code does not simply mean it's only cloud. It can be cloud. It can be virtual machines. Even uh, it can be even physical machines. Even though it is not very easy to configure physical machine, but on physical machines also you can use Terraform to do a lot of provisionings and stuff. So, but mostly Terraform are used for managing your cloud providers and the virtualizations and stuff like that. And Terraform is perfectly great when it comes to the cloud or virtual machines, and also not just machines. It could be anything. It could be any services that your cloud provider offer. Terraform can be used to provision them, and nowadays every cloud provider has adapted Terraform, and they support it a lot. And that's what I will talk about next, and why Terraform is so important today, and why it has become the standard, right? That's what I'll talk about next. So, why Terraform? So why Terraform? Why not any other tools? So as I have already told you, the Terraform has was the first tool that focused only on the infrastructure, right? When Terraform started, their only intention was to automate the infrastructure, whether you are using cloud, whether you are using some kind of VMware or some kind of virtualization, or you are using some hypervisors like Xen or anything. The Terraform focused on all those infrastructures, whether it is AWS, Google Cloud, Microsoft Azure, or whatever cloud provider it is, whether it is VM, Xen, or whatever hypervisor you are using. The Terraform started focusing on infrastructure provisioning area. That was their original focus when they started, and even now that's what they do, and they do it best. And the company started adapting Terraform, and they found the usefulness, and they noticed that most of the company today uses cloud, and many companies uses virtualizations as well, and many companies still use the old data center, or their own premises to set up the machines and stuff. So whatever the case is, Terraform has become a standard provisioning tool in all these providers and all these infrastructures. And then most of the infrastructure providers loved it, because including especially the cloud providers, because AWS, Google Cloud, or everyone, they really want their customer to go through a easy option, right? When they want to provision the infrastructure. And also most of the customer, when you think from customer side or the company side, most of the company nowadays uses more than one cloud. They might have AWS cloud, they might have Google Cloud, and they might have different cloud account that they might be using. So they always needed one tool that can manage all this account under one single umbrella, right? So what Terraform does is, Terraform has different provisioners. It has an AWS provisioner, Google Cloud provisioner, Docker provisioner, Kubernetes provisioner, Azure provisioner. So whatever infrastructure that are available today, Terraform is can be integrated with that, and then you can use Terraform. You can write the code in Terraform. Whatever your infrastructure is, that is not important. Maybe you are using AWS, maybe you are using Kubernetes. You can write what you want to write inside the Terraform as the code, and then it will talk to your infrastructure provider and do whatever is necessary. So that is where Terraform shines, and almost there are no providers today who do not support Terraform. I mean, at least the major ones, right? All major cloud computing providers, they support Terraform, and they actually support. Even without their support, Terraform has developed or created a lot of provisionings, because most of the cloud providers support automation. And Terraform, technically what Terraform does is it talk to your cloud provider and do some automation using the native support provided by your cloud provider. So that is how Terraform has grown as an ecosystem, and today Terraform has become a standard for the infrastructure as code for most of the companies, most of the cloud providers. Terraform is today a standard, and it can be used to easily develop infrastructure in any provider without much hassle, and the community support is awesome, and it's an open source project, and the community supports it very well, and due to many reasons, Terraform is now a, a standard tool that most of the company uses to provision their infrastructure. Great. So let's talk about how Terraform do the operation, how exactly Terraform work, right? So like I told you, you will be writing some kind of coding, right? You will write some kind of coding to define your infrastructure. So you will specify which cloud provider that you want to use, or which provisioner. That's the actual word that Terraform uses. Which provisioner you are using, AWS, Google Cloud, Azure, or whatever. And then you would mention what are the different resources that you want to create inside the provisioner. Do you want to create the EC2 machines in AWS, or virtual machine in Azure, or virtual machines in Google Cloud? What is the kind of resource that you want to create, and what are the properties of the resource that you want to create? So if it is an EC2 machine, what is the AMI that I want to use? What is the operating system that I want to use? What is the instance type that I want to use? What is the security group that I want to use? What is the key pair that I want to use? So all that information I can write it down inside the code, and then I can also write it down, after creating the machine, then record the IP address of the machine. So Terraform want to create the machine, and then you write the code whatever is necessary for Terraform to create the machine. So assume Terraform created the machine, then Terraform will record certain data about the machine. What is the IP address of the machine? What is the instance ID? So all those recording that Terraform want to do. Then this record that you want to use, and then you want to send the same data to some other other code. Maybe you want to provision a load balancer, and the load balancer want to know what are the different instances to be attached to the load balancer. So you will first provision the machines, get the details of the machine, and then that information you will pass to the next step of code. The next step of code will get the details of the machine that got created, then it will provision an infrastructure with these machines attached to it, provision a load balancer, for example, or create a target group. In AWS there are different things. You can actually pass data from one step to the next step, and then you can actually provision an infrastructure, and that's the way how Terraform works. So once you have written the code, what you will do on your laptop? So in your laptop you can install a Terraform command line. There's a Terraform command line that you can install inside your laptop, and then once you install the Terraform in your laptop, then it can read this code, and then it can provision the infrastructure accordingly. And internally, you can, within the code itself, either you can do it within the code, you can specify how to speak to your cloud provider. If you want to speak to your cloud provider, you need some credentials to your cloud provider. For example, you are going to provision a number of EC2 machines in your AWS account. Assume that is what Terraform wants to do. So then Terraform want to talk to your AWS account, right? And then authenticate, and then it has to provision the machine. So whatever credential that Terraform want to use to talk to AWS, those information you can write it down as the code. So like that, many things you can write it down as the code. So the Terraform, when you execute a command, there's a command called Terraform apply. When you execute this command, from the folder where you have kept the code, then what this command does is it will apply this code to your infrastructure, and a infrastructure get provisioned in your cloud provider, assume in this case AWS. So a number of EC2 machines get created inside your AWS account. So this is how you work. And a Terraform apply command can be executed on a laptop, or if you want, you can give this code to your Jenkins server, and Jenkins server can execute the Terraform apply command. So right, every time Terraform apply command get executed with this code, then a infrastructure get provisioned in the cloud. I mean, it's not only for provisioning. If you want to make some change in the infrastructure, right? So you already provision an infrastructure and later you want to change it, so you make some change in the code. You decided that you want to use a different security group to be attached to all the machines. So you specified that a new security group to be attached to all the machines. You put that in the code, and next time when you run the Terraform apply command, it will make changes to the existing infrastructure. It will not provision a new infrastructure, but rather it would change the security group settings inside all the AWS machines. So that is what Terraform can do. Terraform can not only provision the infrastructure, it can also make changes to the infrastructure that it provisioned. And when you are done, so assume you created the machines for some purpose, and then you are done with the machines. Now it is time to delete the machine. You don't need them anymore. Then you can use a different Terraform command. The command is Terraform destroy. You can use this particular command on the same code. Then what Terraform command line does is it will delete the complete infrastructure that it created previously. So so Terraform is a tool that you can install on a machine, and then from that machine you can configure the provisioning. You want to make changes, you want to provision a new infrastructure, or you want to delete an infrastructure, or do some infrastructure management. You can use different Terraform commands to do that, and the Terraform will read this code to act accordingly. Great. So now the next thing, I'm going to install Terraform. I'm going to install Terraform in my laptop. That's what I'm going to do next. I want to install Terraform in my laptop, and I will write some code in my laptop to provision some basic infrastructure, and then using the Terraform command in my laptop, I will provision that code, provision that infrastructure automatically. So let's see that. So what I'm going to do is I have my laptop. And inside my laptop, I'm going to install Terraform. Terraform can be installed on Windows. It can be installed on Linux. It can be installed on MacBook. I'm using a Mac. So you might be using Windows or a different operating system. So a Terraform can be installed anywhere, and I'm going to show you how you can install Terraform. So those who are using Mac, what you can really do is you can go to your command line. Either you can go to the command line, or you can directly download and install the Terraform from the Terraform website. So let me go to the website. You can search in Google install Terraform. Search in Google for install Terraform, and then that's what I will do. Want to install Terraform. So if you are, it can be a manual installation, or it can be an automated installation. If you are using Windows, you can use Choco to do the installation, or you can manually download the exe file and install it. And if you are using Linux, if anyone is using Linux, right, there are different steps for Amazon Linux, CentOS, and Ubuntu. You can use apt-get to do the installation. That's one option. So I'm using a MacBook, and I'm going to do a manual installation. And all of you, if you are using Windows, you can also do a manual installation. Manual installation means you will download the compile binary from the Terraform website, and then you will start using it. It's as simple as that. Maybe the easiest option to do. That's what I will do. So what I will do is I will just click this button. This is the page from where I can download the package, Terraform package. So if you want to use it for MacBook, this is the one that I can download on my Mac, or you can run these two commands. That is also fine. That command will also do the job. To install Terraform, you can use these two commands also. And then if you're using Windows, you can simply download this file, click this file, and then an exe file will get downloaded, and it is a directly executable file. Either you can copy that file into your system path, or you can copy that file into a folder and define your system path. I hope you know how to define system path in Windows. You have to create an environmental variable called path in your Windows PC. You can go to the Windows management page. There you have this option to create environmental variable. So most probably you will already have a variable called path. So you have to edit that path and then add a folder which where you wherever whichever folder you put this Terraform binary, or whichever folder you downloaded the Terraform binary. So that folder you make it part of the path, then automatically you can start running. Or otherwise you can run the command like dot backslash then downloaded file. That is also another option. If you're using Linux, a better option is to use apt-get, of course, right? Because or if you want to download, you can download as well. So yeah, it's up to you. So what I'll do is, I'm using Mac and I'm going to manually downloading it. I just click this button to start downloading the binary, and you can see a zip file got downloaded in my machine, in my laptop. This is the file, and now I'm going to extract it. I can either do it from the command line, or I can do it from the browser. So I'm going to do it from the command line. So this is the file which I have, and I am going to use the command unzip. In MacBook there's a command called unzip. Using the command I can unzip this file, and then once I unzip, then I would get this Terraform file. So I can see the file got extracted on my laptop. So currently it is in my laptop in the downloads folder, and what I also want to do is I want to move this file to user local bin. That is a binary path within my MacBook. So if I do that, okay, I have to use sudo. If I copy this extracted Terraform file to the system path, then from now I can start running the Terraform command. Right, the command will start working. So it is as simple as that. Even on Windows you can do the same thing. So either you can extract it and then you can use dot backslash Terraform, right? Dot backslash Terraform. Either you can do this. This command will actually work. I mean, it's not slash; it should be backslash in Windows. But yeah, whatever. So this command will work. But most recommended way is that you put this binary into some folder, and that folder you add into your system path. Then it will start working. Or maybe if you are not convenient with all that, the best option is that you can actually go with the Choco installation on Windows. It support. If you are using Windows, you can actually use a Choco to do the installation. This single command will do the job. And if it is Choco is not installed, go ahead and install Choco first, and then you can run this command to install Terraform. So installation of Terraform is pretty simple, and it is supported in all kind of operating systems. Okay, so what I want to do today is that I want to create provision and EC2 machines in my AWS account. And I don't want to do it from the browser. You already know how to do it from the browser, right? If you want to provision a new machine, you can go to the aws.amazon.com. You can go to the console, and then you have the flexibility to create. Click on the launch instance button, and that's what you always do every time you want to launch a machine. You click on the launch instance button, select the operating system, and select different settings, and finally the machine get created. But that is not what I want to do today. Today I want to use Terraform to automatically provision a machine inside my AWS account. So let us try that. And first of all, I need some some kind of credentials. But you let's not worry too much about the credentials. So assume currently I have already configured my Terraform to speak to AWS. All you need is in your you should configure the AWS command line tool. If you already know what it means, I already have the AWS command line tools configured in my laptop. So I'm going to take some sample Terraform manifest. I'm going to show it to you. I'm going to show you the code, right? I told you, you write some code in your laptop, and that code Terraform will read, and then it will provision an infrastructure based on what you have written in the file. So let me show you some kind of code. Take a look here. Take a look at this particular file called main.tf. So I have a file, and then first I'm going to tell the first few lines. You can see there's a block called Terraform, and inside this block, whatever I have written is that I specified who is the provider that I want to use. So I want to use AWS as the provider, and I will explain later what is a provider. We are going to explain. So AWS has Terraform support a lot of providers: AWS, Google Cloud, Azure, VMware, a lot of different Kubernetes, different providers that Terraform already support. And I'm not getting into that topic today, but today we are going to use AWS as the provider. And then every provider is basically some software binary, or we can say some add-on to the Terraform software, right? So it has a version, it has a name, and it has a version. So this is the package. You can, let's call it a package for now. And this is the provisioner that you want to install. Some version of that particular provisioner I want to get installed, because this is the provisioner that I will use today for Terraform. And then I can specify the required version of Terraform. It should be above this one. And then I'm going to, okay, forget about all this. Just let's not worry about this. I can just put in. So, So I'm just going to create. So I mentioned some configuration for this provider. The provider that I want to use is AWS, and then I am giving some credentials. I am telling that I want to work with the Mumbai region. AP South 1 means Mumbai region, and then the profile I want to use, I already have configured some credentials for AWS, and I am telling Terraform that you can use the default profile, and I already have configured some kind of credentials. So basically, in these settings, you can tell Terraform how to connect to AWS, what are the credentials, which region on the AWS Terraform will work by default. So all those settings you can configure inside this particular block. So I'm just mentioning, I'm telling Terraform that this is the credential that it should use, and I will explain that later. And then this is the region, Mumbai is the region that Terraform will work by default. So those information is provided, and then I specify the resource. So Terraform is used for provisioning resources. A resource can be an EC2 machine. Resource can be a load balancer. It can be a database. It can be a storage device. It can be anything. So today I'm going to provision something called AWS instance. AWS instance is basically it provision an EC2 machine, right? So AWS provisioners support different modules or different commands, you can say. So it could be instance, it could be load balancer, it could be something else, right? There are different within AWS. There are a lot of things that Terraform is capable of provisioning. So there is something called instance. That is what I am going to use. Instance means it is all about launching an EC2 machine. If you want to create or delete an EC2 machine, this is the particular module that you can use within the AWS provisioner. So it will always have this syntax: the provisioner name underscore followed by the type of resource, right? This is the type of resource that you want to provision, and here you can give some name of the resource. So type of the resource is EC2 instance, and whatever EC2 instance that you are creating in Terraform, you are calling it with a name app server, and then this is the AMI ID that I want to use. So you already know what is an AMI. If you do not, then let me explain what is an AMI. AMI is basically every time you launch a new machine, in the first page you select the operating system, right? You are actually selecting an AMI. So from an AMI, you always launch the machine. It is the AMI, or in other words, it's a machine image from which you are creating the machine. So it depends on the AMI, which operating system that you will run depends on the AMI that you use. So this AMI consists of Ubuntu. So we have been using this particular AMI most of the time, and then right, you got the point. So I want to use this particular AMI. So I want to launch a new Ubuntu server. That's what I want to do. So what I will do is I will go to my code, then I specify the AMI that I want to use. So this is the AMI I want to use, which is nothing but the AMI that I copied for. This is the Ubuntu AMI. And then what is the instance type that I want to use, and I want to create a T2 micro machine. So that's what I want to do. And then something called tags. What are the tag that I want to create inside the machine? So I'm going to give a name to the machine, name equal to this. So this is the code. So I'm just creating a resource EC2 instance, AWS instance. That means uh, an EC2 instance to be provisioned, and this is the name. And then to provision the machine, you have to provide some settings, and what AMI I want to use, what is the instance type that I want to use, and also what is some tag that I want to create inside the machine. I specify those settings, and then I already configured the provisioner, and I also choose the provisioner, install the provisioner, and all these things. So now what I will do is I will apply this file to my AWS account. So if Terraform work correctly, Terraform will read this file, and using the AWS provisioner, it would create an instance type. It will create a instance type called EC2 machine, and this is going to be the name. Then these are the different settings that Terraform will use to provision the machine. So let's run the command. So in my laptop, I go to the command line. I am in my laptop. I go to the command line, go to the folder Terraform and learn Terraform. Yeah, this is the folder in my laptop. It contains the code, and delete all the other files. I don't need them. So I have the file. The file name is main.tf, and I have been demonstrating this main.tm file content to you, right? It has all these settings and the kind of resource that I want to create. So what I'm going to do is I'm going to run a command called terraform apply from the same folder where I have the main.tf file. I'm going to run the terraform apply command. This command will read the file main.tf, understand what it need to do. It understand that using the AWS provisioner, it want to create a create a instance type called AWS instance, and the name if app server, and this is the key this is the instance type it has to use, this is the AMI it has to use, and this is the tag that it want to set. So it will create a machine with all those settings. So just run the command, just run this command and wait. So it is telling me it didn't apply the settings yet. Now it is telling me, hey, you asked me to create this. So AWS instance dot, so basically the instance type dot the instance name, that is the resource what you are creating. So this is the resource that you are trying to create, and then the plus symbol indicate that it is a resource that would get created. So Terraform, as I already told you, Terraform can be used to create a resource, delete the resource, or make change to the resource. So right now, I have written some resource details in the main.tf file, and Terraform apply command tries to create those resources. So this is the resource it is creating, AWS instance dot app server, whatever name that you provided inside the main.cf, and then a plus button indicate that it is a creation process. And then it also display what are the settings of the machine that it is creating. AMI, Terraform already know which AMI to use, right? Because you provided that information directly inside the main.tf file. That's great. And then ARN is basically a ID that AWS assigned to every resources that you create. And Terraform do not know that yet, right? ARN is some information which currently Terraform don't know, because first you have to create the machine, then it get the ARN, and then Terraform can check what ARN it got. Right now Terraform is waiting, right? So it will be non. So that's what this means. Currently, Terraform don't know what is the ARM, but it will get to know soon. And what is the public IP associated with the machine? Machine is not created yet. Right now, it is demonstrating me and it is asking me, do you want to proceed or not? If I say yes, then only it will proceed and it will create the machine. So right now, I am at this prompt and what is the availability zone. And right now, Terraform don't know which availability zone AWS will be creating the machine. So, but all these variables are available. And instance type Terraform is aware. T2 micro, you already explicitly mentioned that inside the file. And get password data, that's also false. Some information Terraform already know. Some information Terraform is waiting for the machine to get created first. So it will tell you these are the information at the end Terraform will keep. So this is the state that Terraform will keep once it applied the settings to the Terraform. So Terraform not only create the resources, Terraform keep track of all the states. So it is asking me, it will tell you what it's going to do. So one resource to add. Yes, I mentioned only one resource, that is an easy to machine. Then I'm not changing anything, I'm not destroying anything. I'm just creating one new resource. So it summarized, this is what you want to do. So do you want to continue? So give yes, type in yes and press enter, and that's it. Now Terraform will connect to my AWS account. And how Terraform got the credentials of my AWS account, it is still a mystery. I'll talk about that later. And right now Terraform is talking to my AWS account, and then it is provisioning a machine for me in my AWS account. So you wait for the machine to get created, not Terraform, wait for the machine to get into running state. That is why it waited for about 23 seconds. Now it's done and the apply is complete. Resources, one resource is successfully created, and then zero change, zero destroyed. So what I will do is I will go to my AWS account. I will verify if the machine got created or not, right? Let's try that. Let's check that. In my AWS account, did it create a machine? Just refresh the page and you can see a machine got created, and it was added with a name tag machine 1 from Terraform, something that I have written in the code, right? In the code, I have already specified no, what is the tag that I want to create, right? This is the tag that I already mentioned, name equal to this. So the tag is already there. And then I can also see the machine was created as a T2 micro instance. And if you cross examine, you can also see the AMI. This is an Ubuntu server, right? It was created from this particular AMI. So everything is done, the infrastructure is provisioned. So right now it's only one simple resource that I created, an EC2 machine that I have created using Terraform. And in real time it does not have to be the case. It could be some 100 machines and 10 load balancers, a few storage devices, and then a lot of stuff that I might want to create. Today I just demonstrated how you can use Terraform and what is the workflow of Terraform, how you can use Terraform to provision an EC2 instance inside your AWS account. So that is done. Now assume you want to make some change to the machine. Assume you want to make some change to the machine. So how you will make change to the machine? I already told you, when Terraform want to make any change, Terraform insist you that you make change in the code, right? From now we won't do any manual job. We won't use browser. We won't click any button in the browser. We are going to use Terraform completely. We will be writing the code. So now let's try to make some change to your AWS machine and let's see what happens. So what I'll do is I'll let's make. So I'm going to make some change in my infrastructure. So today, maybe I will add a new tag. I already have the EC2 machine. I already have the machine that Terraform has provisioned for me. And then I will make some change to that machine. Maybe I will create a new tag. So what I have to do is I have to go to the code in my laptop. In my laptop, I already have written the code. Then over here, I'm going to specify some new tag. Let's say I'm going to mention type equal to app server. I'm giving some, then web server software that I want to run is Nginx. And some, I'm just putting a few more tag. I hope you already know what is meant by tag, right? If you have to do it using your browser, how you will do it? You will come here to your machine, you click on the machine, and then over here click on the tag button. Here you have the option to manage the tags. You can add more tags and delete tags, right? This is what I want to do, but I don't want to do it from the browser. I want to do it using the code. So I modify the code and I specify all the necessary settings that I want to specify. And now I'm going to apply this latest code to my using Terraform, and let's see what happens. So all I need to do is I need to again run the command Terraform apply. So you modified the file. Let me confirm that I saved it. Saved. And now I'm going to run the command Terraform apply again. Now let's see what will happen. Let's run this command Terraform apply after making the changes. So let's see how Terraform behave if you do this. So this is what Terraform is telling me. Terraform will, it is update in place. Terraform will perform the following action. So let's see what it is going to do. So this instance, this will be updated. That's great. In place means that it will not delete and create the machine to do this, because Terraform is smart enough to understand that if you want to add a new tag to the machine, there is no need to delete and create the machine, right? It can actually, adding the tag can be a in place operation. While the machine is running, you can create tag, right? That's a simple operation AWS allows you to do anytime. You don't really have to delete or create machines to do that. Or for a running machine or for a stop machine, whatever machine you have, you can create a tag. So AWS know that, this is not a very complicated operation. I can simply do it. It's not a big deal. And then it will tell you what it is going to create. So you can see Yeah, so whatever is going to change, you can see this tilde mark. So this resource is going to change, and id, it won't change, but the what is going to change, it is the tags that is going to change. And what will change, it is adding two new tags. Plus means it is adding the tag. So type equal to app server is one tag that it will add. Then web server equal to nginx is another tag that it will add. So perfect. And one element is unchanged, and that is hidden. Terraform did not show you. There is already name equal to a machine from Terraform, some, right? It's there. So that one not changed, so it is not displaying me. And that's it. Tags all, yeah, same thing. So this is what Terraform identified. These are the new tags that would get created. Do you want to continue? So I type yes and press enter. Then what Terraform does is it will add the two additional tags to my existing EC2 machine, and it is a fast operation as expected, because it won't take time. So you go back to your browser and go ahead and take a look at your machine and take a look at the tags, and now you will see those two extra tags which got created. Okay, perfect. Now the question is, how Terraform tracked such kind of things? Okay, that is something we will discuss sometime later. So Terraform did something that you probably did not pay attention. Terraform understood that this tag is already there, and then it added two extra tags. So how did Terraform knew that this tag was already there? Actually, Terraform knew that not from by looking into your AWS account, but actually Terraform is maintaining some state of your AWS resource, and that is something we will talk sometime later. Right now, don't worry about it. I will explain that later. So you can see the resource got modified, and it is added with two extra tags, and it's working. And now Terraform want to delete this. It provision an infrastructure. Yes, of course, it is a simple EC2 machine. Now I want to destroy the infrastructure whatever Terraform has created, and that's what I will do next. Terraform to delete the EC2 instance. So you can, what you can really do is, if you want to delete an infrastructure, you can you don't need to make any change in the code, because you keep the code. You can use the Terraform destroy command. Terraform destroy command, what it does is it will delete the existing infrastructure, and that's what I'm going to do. From the same folder where I have the main.tf, I'm going to execute this command, Terraform destroy. A single command, you run this command, then whatever resource that have been provisioned by Terraform apply, it will undo everything, right? So Terraform apply command is used for provisioning our infrastructure. So whatever resource, in our case it's only one, but in real time it can be huge. So whatever resource Terraform apply command created, Terraform destroy command will destroy them or delete them. And then the minus symbol indicate that it's a deletion. If you go up, you can see what is the resource, and a minus symbol indicate that this resource is going to get deleted, and these are the different settings of that particular resource, and all of them will be cleared, and that's why there is minus symbol. Do you want to continue? Yes. So what that means is, so you want to undo an EC2 machine creation. What does that mean? It means the EC2 machine deletion, right? So that is the opposite of creation, of course. So the point what I'm trying to make here is that the destroy command will terminate your EC2 instance, right? Whichever EC2 instance which got provisioned with the Terraform apply command, it will be terminated by this destroy command. So if you go back, you can actually see the machine might have already started shutting down, and it's terminated, and now you can actually see it says destroy is complete, and if you go back to your browser, the machine is completely deleted, machine is terminated. So Terraform can be used to provision the infrastructure, make changes to the infrastructure, or delete the infrastructure all at one shot. So the entire infrastructure get deleted with the Terraform destroy command. So that makes things pretty easy for a DevOps engineer whenever he want to provision an infrastructure. You want to create a temporary infrastructure that consists of hundreds of machines. So he will put all the data in the code. He will run the Terraform apply command. The entire infrastructure get provision, and then he did his testing. He used it for 1 hour, 2 hour, or 3 hour. Then he decided to delete it. When he is done with it, he will execute the Terraform destroy command, and the entire infrastructure got deleted. Whatever is created by Terraform get deleted. So that is a convenient way of creating or deleting your infrastructure using Terraform. Great.